All right, so we are moving on to part 2, or part B, finding the angle. So same exact idea as last time. We need the same exact formulas. So we have to remember that SOHCAHTOA, which meant sine was opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So something that we can do kind of cool with trigonometry is, given a triangle, like this one down here, we can find this angle right here when we don't know any of these two angles. We just know that it's a right triangle. And remember, trig can only be used in right triangles. So we're going to be able to find this angle right here. Probably we'll round to the nearest whole number, but we could find it to the nearest tenth, hundredth, a lot of decimal places if we wanted to. So the goal is going to be still setting up our triangles like we did last time. That X is in that spot. That's why I was calling it before the missing angle. It can be theta or it can be a missing angle. Across from it, we're going to put opposite. Across from the 90-degree angle, we're going to still label hypotenuse. And the leftover side gets the adjacent side. Now, instead of like what we were doing last time, where we found sine, cosine, and tangent, I want you to look through and see which sides do you have something for. We have a number for the hypotenuse, 34. We have a number for the adjacent, 19. But the opposite, we don't have any number from it. So when looking up at these three ratios up here, this involves opposite. This sine does, tangent does, but cosine deals with adjacent and hypotenuse. And we have the adjacent, and we have the hypotenuse. So we're going to strictly work with cosine. I'm going to copy down that exact formula that's up there. And then I'm just going to substitute exactly what I see. So cosine stays, but instead of the theta, we have an X in that spot, in that angle. So let's put an X in for theta. Instead of saying adjacent, let's put a 19 in for it. And instead of saying hypotenuse, let's put 34 in its place. Now you have to have a calculator to be able to do this math. And it has to be a scientific calculator, one that has cosine on it. We're going to press second cosine to be able to get this little -1 up there. It's called the inverse of cosine. And if we put in 19 over 34 in a fraction, it will spit out what that angle should be, as long as everything's in degrees in our calculator. Those basic blue calculators probably have DEG listed in the lower part of the screen. On a graphing calculator, you'll need to press mode. And when you press mode, you want to make sure that degree is highlighted, not radian. And if you press enter, we should be getting around 56 degrees for our X value, which means that angle is 56 degrees right here. Now keep in mind, if this angle is 56 and this is 90 degrees, we could actually find this angle up here as well, because the angles must total 180. So deduct 56 and deduct 90. We're looking at what, like 34 degrees? I should be able to write right on here. 34 degrees for that one, 56 degrees for this angle, 90 degrees for that angle. And so we can find all the angles with trigonometry, not knowing anything except for one angle, the 90 degree, and knowing two sides. So take a look at the next triangle. We've got two sides, a right triangle. We can find basically the other two angles. So focus on the one angle that you have theta in for, and across from that, label it opposite. Across from the 90 degree angle, label it hypotenuse, and that leftover side, label it adjacent. Now, same thing with before. I've got numbers attached to two of these sides, not the opposite, so I'm going to kind of cross it off, not killing it, but just giving it a little light cross off, and I even circle the two sides I have. That makes it pop out at me. I'm using cosine again, not sine, not tangent. Turns out I'm using cosine for this one. I copy the exact formula down from the top part and fill in with the appropriate information. Theta is the angle we're looking for. I'm going to call it theta. Adjacent, we're going to put a 21 in its spot. Hypotenuse, we're going to put a 26 in its spot. And again, nobody, even a genius, could do this in their head. You need to grab a calculator, type in second cos, so that it will pop up this cos with a little -1 up top, and type in 21 over 26. And you may want to close those parentheses because it might just only do the cos of 21. We want it to do the whole fraction, and that will give us what theta is. If I type that in, I'm getting 36, and that means 36 degrees for that angle. And again, if I find out one angle is 36, then basically I can figure out the other angle, probably, let's see, 180, take away 36, take away the 90, 54 degrees. So let's talk about a few things for number 3. Notice, it's a right triangle, and you have two sides. We could find this third side using the Pythagorean theorem. We don't need to, but we could. And then if we had this third side, we could solve this using sine, using cos, or using tan, because we would know all three sides. So we could use the opposite and the hypotenuse for sine, adjacent hypotenuse for cos. We could use any combination because we've got all three sides. And it will work out to the same answer. In addition, we could work from this angle if we wanted to, and in the end, find the bigger angle over here if we wanted to. You can do a lot of things in different orders. I think it's probably easiest just to use what we're given because we are given enough. From this angle, if we stick with what we're given, this side's the opposite. Other side, across from the 90 degrees, the hypotenuse. And that leftover side is the adjacent. This time, it looks like the adjacent has no number attached to it, so I'm not going to use that. That means when I look up top, the only two sides that I want to use right now is opposite or hypotenuse. Otherwise, I've got to do some work to find the adjacent, and it's just basically extra work. So if I look up at the top, opposite and hypotenuse, that's sine. So write that whole formula out so that you have it all settled how it's supposed to be. Does matter what's in the numerator and in the denominator. This time we have theta as the angle, so I'm leaving it all the same there, but I'm going to put a 7 in for opposite, a 9 in for hypotenuse. And the only way to get this separated is by pressing second sign in your calculator and getting that little -1 next to the sign. And typing 7/9 in close parentheses, and that will give us a roundabout what that angle is. When I do that in my calculator, I'm getting around 51 degrees. So that means this angle here is 51 degrees. I could have worked from the other angle, and if I did, I would have gotten that this angle is 39 degrees. And then I could work backwards and say, well, if there's 90 degrees here, this one must be 51 degrees, because total, it needs to add up to 180. All right, same thing with number 4. We could work from the other angle, but let's work from the x. We could also find the hypotenuse here if we wanted to, using the Pythagorean theorem, but it's going to be in a decimal. So that's not going to be fun to work with. So using what we got, let's see if we can figure out side opposite is 11. Side across from the 90-degree angle, hypotenuse. Adjacent's our leftover side. Look carefully. We don't have a number associated with the hypotenuse, just the adjacent and the opposite. If you look up at the top, we don't want to use sine. We don't want to use cos. We want to use tangent this time. Copy the exact formula as we see. This is trigonometry. It's not stuff people do in their heads. Substitute in an x for the theta. Opposite, we're going to put in an 11. Adjacent, we're going to put in a 12. And the only way to separate this is to do second tan in our calculator of 11 over 12 and see what it gives us for x. When I did this, I'm getting like 42.5, and this is degrees in the triangle. You can say 42.5. You might even want to round to 43. A lot of times we use the nearest whole number, because when we go to then put numbers into this triangle, because keep in mind, this is 43 degrees right now. Then when we try to figure out the other one, it will also be in a decimal, makes it a little bit more tricky. 180, take away 43 up here, 90 here. I think it's 47. And we can find that other angle as well. May not be necessary, but we sure can do it.